Welcome back. I thought it might be helpful to spend a little time talking about the index match function. It's a function within Excel that I found to be very, very helpful when working with data. It's actually a combination of two different functions, index and match. Now, consider the data on the top left-hand corner. We have produce, apples, corn, oranges, and potatoes, and we have the price for each respective item. Now, the first thing we want to do is identify the row number within the data. So within the data, A2 to A5, and we're going to select apples. Where is apple within the data? It's the first item. We would type in match D2, which is apple. Where is apple within A2 to A5? Match D2, comma, A2 to A5. And that produces number 1. If we were to change the apple to, let's say, potatoes, that would return a number 4. The potatoes is the fourth item down within A2 to A5. Then what we want to do is find the respective price associated with each item. That's the index. Index means to search or to find. So index B2 to B5, search within B2 to B5, and return the price associated with G2. What is G2? That's number 4. Remember, number 4 reflects where potatoes are on the list. It's the fourth item down. What's the price that corresponds with the fourth item down? $2.25. We would write index B2 to B5, meaning search within B2 to B5 and return to us the price in the fourth position. That would be potatoes, $2.25. If we were to change this to corn, corn would match with us the second position. And then the index would tell us that the second position within the prices is $2.01. We can put it together and we would type it just as follows. Index B2 to B5, meaning first, search within B2 to B5, the prices, and match it with the column number. D2, which is corn. Where's corn within its own respective list? Number 2. So index B2, B5, and number 2. What is the second position within the cost? And that would be $2.01. Okay, so that allows us to match the price for every respective item. Consider the second data set over here. With data set number 1, that's the S&P 500 closing prices for a couple weeks. Data set number 2 is Bitcoin during the same period of time. Let's say, for example, we wanted to find out what was the price of Bitcoin at the same time for every respective S&P 500 closing price. Well, the first thing we would do to find the S&P 500 prices, and this is the whole formula together, is we would write index B3 to B17. Find for us B3 to B17, what is the price, and match it with G3. What's G3? That's the date, September 2nd. Where was the S&P 500 on September 2nd? We would match G3 within the S&P 500 date range, A3 to A17. In the second example, we're looking for the same date, respective Bitcoin prices. So index E3 to E17. Find for us the price for Bitcoin and match it with G3. G3 is again the date, September 2nd, where it was G3 within the date range of D3 to D17. You'll notice, by the way, we have a 0 at the end of this formula. A 0 indicates we're looking for only exact matches. We could put in a -1 or a +1 if we're looking for the closest match that's above or below the ideal value. Most of the time I use the 0 though. If you're looking for a date range and you don't have the exact date price or the exact date value, then the -1, +1 variable can be helpful. Also, you'll notice that we have dollar signs within these formulas. The dollar sign allows us to lock in an absolute reference, meaning that if we were to search without the dollar signs and we were to drag this formula down, it would then not search for G2 to G17. We would drag it down one cell and it would search for G3 to G18 and so forth. So if you want to lock in a specific set of data and not have that data reference move as we drag the cells around the Excel sheet, then we can add in the dollar signs. We hope this has been helpful. We look forward to seeing you back soon.